Factoring a polynomial completely. Our last two sections, our last two parts for section 7, 8 are going to be centered around factoring these polynomials completely. So in this first one, I have created, the textbook doesn't have this, but I have created basically a bit of a flow chart that kind of helps guide you through that factoring process. So you start at the top. So we're going to start up here at the top. And basically, you work your way down depending on what type of polynomial you have. First, number one, your very first step is to always look to factor out any greatest common factor. Okay, what I mean by that is, so for example, if I have a 2x to the third plus 6x squared minus 2x, and I'm asked to factor this completely, the first thing I'm going to look for is, do any of these terms, it's got three terms, do they have any factors in common? Well, these are all divisible by 2, and they all have an x. So first thing I'm going to do is factor out that 2x. So 2x times x to the second gives me that first term, plus 3x gets me that second term, minus 1 gets me that third. And then always as we go, double checking to make sure it distributes back. So here, if I multiply this back, I get 2x to the third. If I multiply 2x times 2x times 3x, I get the 6x squared. And 2x times negative 1, I get the negative 2x. Okay, so now what I've done is I've identified one of the factors. Here's one of the factors right here. Here's the other. But I'm not done. Now I need to look to see if, well, excuse me, if what I have left here factors. Well, this is a trinomial, 3 terms. So now I'm done with factoring out the greatest common factor. They have nothing else in common. So now I look at, well, how many terms does what I have left have? So here's my one factor. So we found one factor. So here's our one factor. And then here's the other. We're going to look to see if that one goes any farther. We don't have to worry about this one because it's just a 2 and it's just an x. There's nowhere to go with that one. But now we're going to look at this guy. How many terms does it have? Okay. So if it has 2 terms, if what we have left has 2 terms, a binomial, we want to look for that difference of squares pattern. If you don't remember what the difference of squares pattern is, it tells me if I have something squared minus something else squared, it's going to factor into a plus b, a minus b. An actual physical example for that is if I have 4x squared minus 49. This 4x squared is the square of 2 and x. If I take 2x times itself, I get that. The 49 is the square of 7. So this is going to factor into 2x plus 7, 2x minus 7. And again, just like all our other previous factoring sections, you want to check it, make sure it works. 2x times 2x is 4x to the second. 2x times negative 7, negative 14x. 7 times positive 2x plus 14x. Positive 7 times negative 7 is negative 49. These add to 0. 4x squared minus 49. Check, it worked. So there's how it factors. Okay, so if you have two terms, it's a binomial, then we want to look at that difference of squares pattern. Okay, in this one that we were doing up here, what was left had 3 terms. If it's got 3 terms, we want to look to see, well, is the leading coefficient 1? In this case, it is. My leading coefficient is 1. Since my leading coefficient is 1, I'm going to guess and check it. Okay, so here we are factoring x squared plus 3x minus 1. Let's write down here x squared. Again, my 2x is just hanging out there. This 2x is one of our factors. So I'm looking what multiplies to give me negative 1, adds to give me 3. Well, the only thing that multiplies to give me negative 1 is 1 and negative 1. As far as I can tell, there's no way of adding them to get 3. So it doesn't factor. There will be some things that won't factor further, and that's really as far as you can go with it. So this is as far as I can go with it. Now, if there was something else there, we could guess and check it, but that's as far as that one will go. But again, that's that guess and check process from way back section 7.4, I think. Now, if the leading coefficient is not 1, okay, if the leading coefficient is not 1, for example, for 4z squared plus 4z minus 3, there my leading coefficient is not 1. I can either guess and check it, like we did in section 7.6, or I can organize factor it like we just did here in section 7.8. Okay, so I could organize factor this. How organized factoring works, again, I take the 4 times the negative 3, which gives me that negative 12. I want to multiply to give negative 12, add to give 4. So we're looking at 1 and 12. One of them has to be negative. Nope, that's 11. 2 and 6, negative. Ooh, that one works. That one gives me 4. So I'm going to replace this 4z with a negative 2 and a 6. So 4z to the second minus, we'll go plus a negative 2z plus 6z plus a negative 3. So there, I have my 4 terms. And then now we group. Okay, so we're going to group the first 2 plus 6z plus a negative 3. And then we're going to factor out common factors. Out of these first 2, I can factor out a 2 and a z, and I'll be left with 2z minus 1. Out of these 2, I can factor out a 3, 2z minus 1. They both have this 2z minus 1 in common, so I would have 1 2z minus 1. And then the 2z from here plus the 3 from here. So there I am factored. Of course, we want to check it, make sure it works. So multiply it out. 4z to the second plus 6z minus 2z when we distribute minus 3. Put like terms together. 4z to the second plus 4z minus 3. Oh, excuse me, sorry. Okay, so that's if it has 3 terms. If it has 4 or more terms, we're going to factor it by grouping, which is just what we did back here. Factoring by grouping here at 7.8. Okay, rearrange it, put like terms together, or basically just like what we did in this organized factoring. You're going to work through this process right here. Okay, all right, so let's go ahead and let's do a couple examples. Okay, so factor. So step 1, look for common factors. Do these 3 things have anything in common? That's always the first thing you do. It makes life easy when you can get that. Well, they're both multiples of all multiples of 3, and they all have at least one x. So I'm going to factor a 3 and an x out. So 3x times what gets me this 3x to the third? Well, I'm going to need x squared. 3x times 2 gets me the 6, and I need one more x. And then 3 times 6, and I have the x. So now I want to double check. If I distribute this in, 3x times x squared, yep. 3x times 2x, yep. And then 3x times negative 6, yep. Okay, so then now we have 3x times x squared plus 2x minus 6. So I have one of the factors. Here's one of my factors. And then here's the other, but this one might factor further, so we need to double check it. So we come over and look. How many terms does it have? Well, it's got 3. Leading coefficient is 1, so we're going to guess and check. So I want to multiply to give me negative 6, and I want to add to get 2. We've got 1 and 6. One of them's got to be negative. Let's make the 1 negative. That adds to 5. Nope, that adds to 5. We want to add to 2. And then what we have, negative 2 and 3. Well, that adds to 1. Ooh, those are the only factors of 6. So I'm done. This is as far as it goes. I won't factor any farther. Okay, next, last example we're going to do for today. Okay, again, factor out common factors. Very first step always. Both of these are multiples of 7, and we have some x's in common between the 2 terms. So I'm going to take out a 7. How many x's can we take out? This one's got 4. This one's got 2. I can only take out the most they both have, which would be 2 of them, x to the second. So I took that 7 out. I'm going to need 2 more x's for me to multiply this in and get 4 x's. Then minus 7 times 4 is 28, and then x squared I already have. Okay, so here I found one factor, but technically this here technically is like 3 factors. It's a 7, an x, and an x. But we shorten it up and write it this way instead of having to write all 3 of these out. And now we look at this factor and see, does this one go any farther? Well, how many terms does it have? Oh, sorry. It has 2 terms, binomial difference of squares. So we want to look, are they squares? Ooh, they are. This is the square of x, because x times x, and this is the square of 2. So that tells me this is going to factor into x plus 2, x minus 2. Again, we can check it. X times x, x to the second, minus 2x, plus 2x, minus 4. Those add to 0, x squared minus 4. Yep, x squared minus 4. Okay, and the only thing I can't forget is I have that 7x squared out front. So there we are right there, completely factored. Yay! Okay, now your practice. On page 407, I want you to do 12 through 22 even.